In problem 57, we want to find alpha. Alpha is the level of significance. It's also a type 1 error. Type 1 error is the probability of rejecting H0 given that H0 is true. Okay, you don't want to reject a true hypothesis. So what would make H0 true? H0 is true in this case if mu is equal to 200. Okay, so those mean the same thing. H0 is true or mu equals 200. When would we reject H0? We would reject H0 according to the problem if the mean of the random sample, I'm just reading along here, if the mean of the random sample of 100 items is more than 212. So reject H0 if x bar is greater than 212. So we want to calculate the probability that x bar is greater than 212 using the fact that mu is 200. So we're going to standardize this problem. X bar greater than 212. Standardize that, assuming H0 is true, and you'll get P, the probability that Z is greater than 1.5, and that makes your alpha C. In 58, you're asked for the critical value of a Z interval, confidence interval. Well, the confidence interval is 80% confidence interval, so we've got to find Z star where for the 80% confidence interval, and if you refer to the last row of the t-table, you'll find it for 80%, it's 1.282. So the answer is D. Alright, let's interpret the computer output. The problem here is a two-tailed test, so we need the p-value for the two-tailed test. These are all p-values, but this one is the p-value for the two-tailed test, and it's 4.51%. And we need to test this at the 3% level of significance. So that means this needs to be less than 3, and it's not. So that makes it fail to reject, right? So we're going to fail to reject H0 because the p-value, 0.0451, is not smaller than 3% or equal to 3%. It's actually bigger. So we pick B. In problem 86, we want to calculate the sample size required for a 90% confidence interval with margin of error of no more than 0.8. Okay, so we put all the elements together in our formula for the sample size estimation. So N would be 1.645 times the given standard deviation of 4 divided by m, which is 0.8, and we square that whole thing, and we should get the answer of 67.65, which you round all the way up to 68. So the answer is A. The standard error of the mean is just S over N, square root of N. S is 0.2, N is the square root of 4 or 2, so the answer is 0.1. So that's A. What about 95? In 95, we want to calculate a p-value Okay? For a two-sided test. This test, what is it, a Z or a T test? Well, we're told about assessing the accuracy of a laboratory scale, a standard 20-gram weight. If the scale has no bias, the average weight would be 20. Suppose you weigh 9 times and obtain a mean weight of 19.997 and a standard deviation of 0.003. So this gives indicates that we use the t distribution because this is S. So we would calculate the t-stat first, and the t-stat is our mean of 19.997 minus the 20 as the hypothesized value over S 0.003 over the square root of the sample size 9 times. The t-stat works out to be -3. Alright, so we're going to test using the t 8 degrees of freedom distribution, and we're going to see the probability, the p-value, as 2 times the probability that the t8 distribution is higher than our t-stat of 3, right? Because we got a -3, but we're gonna it's symmetric with our chest on the tail, left of -3 or right of +3. So I'm going to go this way since the t-table works on the right side. And what do I get? And so this is going to turn out to be 2 times between, this means between 0.5% and 1%. Okay, if you look at the table, the 8th row, 3 falls between 2.896 and 3.355. So that's between 0.5% and 1%. But now I have to multiply those by 2 to get my real answer. So the answer is between 1% and 2%. So the answer has to be B.